Okay.
Chapter 2 review today. On Thursday, the homework is due. Make sure you show up with it already. Assignment page filled out. Everything in the right order. Everything stapled. Okay, everything totaled up, your name, first and last name on it. The longer it takes to collect all the homework, the longer it takes to get that test started. As soon as I've gone through all the homework and double checked everything is all the T's are crossed and the I's dotted, pass out the test. Next Tuesday, we start chapter 3/4. Don't take the day off. The next day, we start a new unit. I mean, I don't know what that's about, but some people do. Okay. One thing I want to say, that it's happening more than it should be. I'm just going to reset, maybe this just need to be rehead one more time. On the very first day, it's in the syllabus. There's no test or quiz makeups. There's no test or quiz retakes. I'm getting emails saying I'm not going to be able to be there, whether you're sick or whatever reason. Some people are offering units. It's a couple of people, 3 people, 5 people, whatever. All classes. Trig, 3A. I have a doctor's note. What am I going to do with a doctor's note? I'm not going to, it's not like I can clear absences. Absences are just absences. Excuse, not excuse. All I'm doing is keeping track of when you're here or when you're not here. I have to turn in the, attendance. I keep track of attendance all semester long, but for the most part, it's the first 9 weeks that, are you going to be dropped or not? 6 absences in the first 9 weeks, dropped. Unless we're communicating. Communicating, then we have, we have something to work back on. Some people got dropped and they want it back in. So have them go back to the counselor, they petitioned, and then I'll sign whatever you want if you want back in. But it's not fair to the people who show up on test day that you get to take it at a different time. Because I want to be able to give the test back as soon as I can, but if we're waiting for another person to take the exam, I can't give them back until that person takes the exam. In addition to that, I'm not going to be put in the position of saying no to one and yes to another. And it's like, why did they get to and I didn't? And like I said on the very first day, the answer is no to everybody. That's why it's built into the class in the syllabus. At the end of the semester, your 2 lowest quiz scores get dropped. So if you've missed 2 quizzes, hey, the zeros get dropped. Watch your quiz average go up really quick. The final counts twice, provided it's higher than your lowest test score. So your lowest test score gets replaced by the final, provided it's higher than your lowest test. So if you miss the test, it's a 0. If you get a 75 on the final, then the 0 becomes a 75. Or if you have a bad day on the test, you got a 30%, and you get a 75 on the final, the 30 becomes a 75. And that's across the board for everybody. That's the only way to make it fair in my mind and not sit there. If we did makeups, you can't take it this Tuesday, then okay, we'll figure out when you can do it. I would have a line out the door of probably half of the class that won't be here on the day of the test. The test shakes or whatever you call it. The anxiety, whatever. I get it. But that's not how it works. And again, I don't want a doctor's note because I'm not going to worry about it. I don't want to be involved with the HIPAA laws. I don't want to know what's going on. That's all. So it's not about like clearing absences or anything. It's about just communicating. If you're absent, you're absent. That way I know instead of putting an absent, I put EM, which is emailed me, and I know why we communicated. That's all. What and why. Any questions? I get dizzy when I stop walking. I'll get a doctor's note so you guys know what's going on. Oh, vertigo. Really weird. Okay. I think I'm just going to do this. I'm going to show you test versus quiz on the test versus review sheet up here. It's a little smaller, but it's very specific. Okay. The review sheet's on the left and the test is on the right without problems. And as you can see, the test is 140 points, 10 points each. And over here, we have 1, 2, 3, and 4. Perform the operations and write the result in standard form. Same directions. Write the quotient in standard form. You are going to have one question like number 1. You're going to have one question like number 2. You're going to have one question like number 3. You're going to have one question like number 4. Basically, you're going to have one of each question, 1, 2, 3, and 4. Okay. Numbers 1 through 4, one of each. So you're going to have an addition or subtraction. You're going to have multiplication. You're going to have something you have to FOIL out or square out. And you're going to have a rational expression where you have to multiply by the conjugate to simplify the fraction. Just like the quiz. Just like the quiz prep. That was a bonus. Number 5, 6, and 7. Solve by factoring. Solve by factoring. There's one problem. Solve by factoring. So numbers 8 through 10. So take that back. 5 through 7. There's one where you have to solve by factoring. Now I haven't moved the camera. Eight through 10, complete the square. There's one question where you have to do the complete the square method. There's one of them. 11 through 13, quadratic formula. There's one question that you have to use the quadratic formula. One of those. Then 14, solve using any algebraic method. You must show appropriate work to receive credit. All of those have the same directions, all the way through number 20. Solve using any algebraic method. You must show appropriate work to receive credit. Numbers 8 through 14. Solve using any algebraic method. You must show appropriate work to receive credit. So for numbers 14 all the way to 20, basically you're going to have one of each. When I say one of each, you actually are going to have, now a little bigger, you'll actually have one that looks like this, and one that looks like that, and one that looks like this. The one that looks like that, and one that, I mean, literally, one of each that looks like exactly what you have. Just different numbers. You're looking at a copy of the test with different numbers. You have examples of the bonus question. Sorry for the left hand or the right hand side here is a little fuzzy. How we do this? A little bit. This is the mock-up on the test. The first two questions. Bonus. Perform the operations, write the result in standard form, got to show appropriate words. Perform the operations, write the result in standard form. On the review sheet, bonus question. Question, and they're not the same order. Number 4, perform the operation, show appropriate word. Number 5. Basically, it says simplify, but the direction will basically almost say the same thing. Perform the operation, show appropriate word. In other words, you're going to have one like 4, you're going to have one like 5. Okay, 4 and 5. Thanks. It says number 3 and number 4, solve using any algebraic method. Back to the review. Potential bonus number 3. This is the solve using any algebraic method, just like your quiz with decimals. Round to the nearest thousandth on there. And then these down here, solve using any algebraic method. Forget about 7. It will be just like number 6. I'm just going to eliminate, don't worry about 7. It'll be just like number 6. Because we went over an example like number 6 last week from 2.5. So you have one like 4 and 5. You got one like bonus, potential bonus 3, potential bonus 6. And then last but not least, the last 2 bonus questions, you have another use the quadratic formula, complete the square. This is where the tougher quadratic formula completing the square problems will be, where you might have to work the fractions. Same steps. If you have fractions and you compute using the quadratic formula, undo the fractions first, so you don't plug in fractions. Please don't plug in fractions. You want an example of it? Hey, how about the one I put on the review sheet? Hey, one of these. Oh, right here. Sorry. There you go. No fraction. You have fractions there. So those would be good bonus questions. And then complete the square. Okay, so use complete. Where do you go? Hello. Oh. There you are. Complete the square. I bet you got to use fractions there. And then again, I wonder if I gave you a complete square where fractions would end up. Oh yeah, number 10. And even number 9 would have some fractions in it. So you have examples in the review sheet of the bonus level. Or 14 questions at 10 points apiece, 140 points. 6 bonus at 5 points each, 30 bonus. Gives you 170 out of a potential 140. So when you say, is there anything I can do? Yeah, ace this test. Please remember, the right answer does not get you full credit. The work has to support your answer. You must show appropriate work to receive full credit. I had plenty of calculator responses on the quiz. They did not get full credit. I'm not going to give a calculator full credit with no work. Work has to justify your answer. And some of you who you're losing points not because you're not doing it correctly, but because you're losing points, you're not being able to figure out what you just wrote. You're getting lost in your own handwriting. You're losing negatives. You're losing, a 3 looks like an 8. You're transposing a 5 into a 2. 7s and 1s get confused. An I and a 1. Some don't use a sharp pencil. You're losing points primarily because of neatness. And it's not me trying to figure out what you wrote, it's because you're not neat about it, so you're not understanding or seeing what you wrote in the last step. That's causing missing points. I try to follow it and try to find where the error happened. But a lot of the times, everything is scattered, and when it's scattered and messy, that's where you're missing your points. You can clean it up, or you can do better. Okay. All right, real quick over here. Wrong way. There is an edit on homework 2.5. Omit 33 to 45 every other odd. So in other words, it's just this. In fact, actually put it up here. That's the new 2.5. 5 to 29 every other odd, and the 47, 51, and 53. There's nothing like 33 to 45 on the test. And if you need to sign the sheet, they're up here along with the review sheet if you need one. Tell me what you want to see. Number one. Number one. 3 times the square root of 192 minus 6 times the square root of negative 200 plus negative 2 times the square root of 75 minus 4 times the square root of 242. And I want to also make sure you remember on Thursday, even on Wednesday if you want, you're welcome to come to the co-rec at 8:30. Office hours at 7:30. Co-rec starts at 8:30. On Thursday, we're reviewing before the test at 8:30 to 9:45. Same thing with tomorrow, 8:30 to 9:45. They take the test tomorrow. So you're welcome to come to either co-rec if you're around. So before we can actually add these together, it's all about order of operations. You got to do what's inside the parentheses. So we're going to simplify what's inside. This is the getaway card. So you're going to bring down 3. And we want to break out whatever we can break out of square root 192. So you got to think about what goes into 192. That's anything. Give me two numbers that multiply to make 192.
16 and 12.
16 and 12. 16 times 12. So we have a 4 times a 4, and we have a 4 times a 3. Don't worry about, okay, if you do that, if you go 2 times 2, a 2 times a 2, a 2 times a 2, and a 3. Then here's what's breaking out. A 2 breaks out, another 2 breaks out, another 2 breaks out, and you have a 3 back in square root jail. Okay? 2 times 2 times 2 is what?
8.
8. So this is 3 times 8. But here's some advice. Look at the 2 square roots that you're going to add together. So look at this one. 3 square root 192. That's going to be an imaginary. That's going to have a 9. Over here, negative 2 square root 75. That's a real number. And I messed up because that's supposed to be imaginary. That's supposed to have a negative in there. That's imaginary. So these two will add together, and then these two would add together. First thing you should always do, and I think you've been told this before, you should read the problem before you even begin it. Always read the problem. Read the question. Then do the problem. Which one's probably easier to figure out the square root simplified? 192 or a 75?
75.
75. So let me backtrack. We have a plus, we got a principal. Right? Getaway card, negative 2 times 2 numbers. 3 and 25. 3 and 25. 3 and a 25. So a 3 and a 5 and a 5. So a 5 escapes and a square root 3 left behind. Okay? I'll come back to the rest of it. So this is going to be negative 10 and a square root 3. I'm supposed to combine like terms. The only thing that's going to combine with this is another something with a square root 3. That gives me an incredibly good hint as to what goes into this and what I should factor with. It gives me an incredibly smart hint that I should have a 3 left over in the square root so I can break this apart. 3 goes into this 64 times. So if I did that one first, I know I have a 3 left over. So if I go 3 on your calculator, not 192 divided by 3 is 64. And that's 3 and 8 and 8. So my getaway car is a 3. 8 breaks out and a square root 3 left behind. So using the other one before this one gives you a hint because you're looking at this one's simpler to do than that one. I said that backwards. Square root 75 is easier to figure it out, and it gives me a clue as to what should be left behind. So I divide by 3 first. Oh, look at that. Nice, perfect square. Okay. It doesn't matter because when we went you came up with 16 times 12, I'm not sure I would come up with 16 times 12. So if it was square root 192, sometimes 2 times, this would have to be 96, right? No? Yes? 2 times 96, 192?
Yeah.
Yeah. So 2 times, and I'll go 2 times 48. Now I got 2 times of 2 times, I keep going with the 2, 2 times 24. I'm on a roll. 2 times, 2 times, 2 times, 2 times 12. And keep on going. 2 times, 2 times, 2 times, 2 times, 2 times 6. So 2 times, 2 times, 2 times, 2 times, 2 times, 2 times 3. Here's a pair of 2s, one escaped. There's another pair of 2s. There's a 2. There's a pair of 2s, another 2. 3 left behind. 2 times 2 is 4. 4 times 2 is 8, square root 3. Doesn't matter what you use. What matters though is if you don't bring down all the 2s, you're going to forget they were there. You might just see those. I think we have just 4, 2 square root 3. If you don't bring all the branches down. But here the getaway car is a -6. Times. Now let's use a little bit of thinking before we begin. We're hoping that these two are going to combine together. Which one do you think is simpler to work with? The square root 200 to simplify, or the square root 242? The -200. So poke out the I. Square root of a negative, you're going to poke out that I. Now, 200, that's 100 times a 2. 100 is 10 times 10 and a 2. A 10 will escape and a square root 2 left behind. So when you simplify this square root, you have an I square root 2. So the only thing that's going to combine with it is another I square root 2. So when we simplify that other radical over, it's going to have to be an I square root 2. So it's -4. Getaway car is -4 times, I'm going to factor or divide by 2. So that's 2 times 121. Poke out the I. Forgot to poke out the I. There. I did myself. And then we have a 2. What is 121? 11. 11 times 11. It reminds you of that Ice Cube concert I went to last week when they broke out into a World Series. 11 escapes. Square root 2 left behind, and there it is. This is an I square 2. That's an I square 2. Now, it doesn't have to take this long, but I'm just trying to get you to have some thought about it. Not random, but just some thought about it. Think about it before you actually do it. 192, well, oh yeah. This will help me do that one. Or if this one, you figure it out, then whatever you get here, whatever's less than the radical, you're probably going to need it over here so you can actually combine them together. I shouldn't get a different kind of square root here and here. They should be the same kind because those would be like radicals. In here, 3 times 8 square root 3 is 24 square root 3 minus 60i square root 2. And this is going to be plus a negative. Negative 2 times 5 square root 3 is minus 10 square root 3 plus negative 4 times 11 I square root 2 is minus 44 I square root 2. So your like term. 24 of these square root 3s minus 10 square root 3. 24 of them minus 10 of them leaves 14 of those square root 3s. And then you have negative 60 of these I square root 2s, negative 60, and then a negative 44 of the I square root 2s. negative 60 of them, another negative 44 of those I square root 2 is a negative 104 of the I square root 2. Reminding you, the I should go between the coefficient and the square root, not here. Because some of you wrote it that looked like this. And it looks like the I is inside the radical. That's wrong. I also know that's how calculators tend to write their answers, which means now I know the I is not inside the square root 2 because it's in front of me. Simplify, combine like terms. So that's number one. What else?
So 13.
13. Quadratic formula. I'm not going to show the whole thing. I'm just going to show the first step. Quadratic formula. This first step right here. Rewrite the equation in standard form. Standard form is ax squared plus bx plus c equals 0. Make one side equal to 0. Undo fractions if necessary by multiplying every term by the least common denominator. Do not plug fractions into the quadratic formula. You're going to have a mess to clean up. And if you want to plug in fractions into there, I have to be extra microscope on how you're going to calculate that. If that's what you want to do, then you're going to basically put a spotlight on your work, because now I got to figure out, well, look at that. I'm impressed. Let's see if they can actually do it. Okay. You don't have to plug in fractions, and you shouldn't undo the fraction. We've been talking about that all semester. This one's got fractions. I don't want divided by 3. That one's divided by 3. What's the only fraction we have to undo? Divide by 3. So what's the least common denominator? A 3. That's what it's going to take to undo the fraction. Everybody gets multiplied by 3. So every term gets multiplied by its own 3. Don't forget this side. This reduces. It's 14x squared plus 63x minus 35. And that's a 0. Okay. Say that horrible curse word. Thing. Is he serious? Would he give us something like this? Make a list of A, B, and C? What would A 14? B is 63 and C is negative 35. And you're going to go X is equal to the opposite of B plus or minus square root. Inside you got B to the second minus 4 times AC all over 2 times A. I mean, just thinking here, 63 squared. We're talking huge numbers. I've said it once, at least once. I really try not to be an asshole. Really try. My wife may say no, but I try. Think 14, 63, and 35. They all have a 7 in common. I can factor out 7 and have smaller numbers to work with. This is now 2x squared plus 9x minus 5 equals 0. So now A is a 2, B is equal to 9, and C is equal to negative 5. And those are much nicer numbers to crunch in the quadratic formula. I'll get the same answer no matter what. Here we go. I'll do the big numbers first. X would be the opposite of 63. Okay. Negative 63 plus or minus square root. I have to see the substitution. So parentheses 63 squared minus 4 times A, which is 14, times C, which is negative 35, all over 2 times A, so 2 times 14. Okay. Little bit at a time. Simplify what's inside. Negative 63 plus or minus square root. Maybe she three to the second. 3,969. Minus a negative times a positive times a negative. What's that going to be? Going to be plus 4 times 14 times 35. Okay, 1960. All over 28. So negative 63 plus or minus. The square root of 5,929. All over 28. Which is a nice 77. X is equal to negative 63 plus or minus 77, all over 28. If you can go further, you have to. We can actually combine 63 and 77. So you separate this into X equals negative 63 minus 77 over 28. And X equals negative 63 plus 77 over 28. X is equal to, that is going to be 140, negative 140. Over 28. And 14 goes into both. This is 14 times 10. Actually, 14, and sometimes 14. 14 times 2. This goes in 5 times. 2 goes into 10, 5, so X equals 5. 77 minus 63 is 14. 14 over 28, which is a half. So X equals 1/2 and a 5. So you can get there. It's ugly, but you can get there. Versus, still B, plus or minus square root
E squared minus 4AC. All over 2A. Opposite of 9. Plus or minus square root. E squared, 9 squared. Minus 4 times 2. Times C, negative 5. All over 2 times A, 2 times 2. X is equal to negative 9 plus or minus square root 81. Is it going to be a plus or a minus? Plus negative times a positive times the negative will be a positive. Negative times the negative can be a plus. This is 4 times 2 is 8 times 5 is 40. Plus 40 all over 4. 81 plus 40 is 121. So this x equals negative 9 plus or minus square root of 121 over 4. What's square root of 121? And that, so this is x equals negative 9 plus or minus an 11 over 4. And that can be simplified because you can combine negative 9 and the 11. So separate it, negative 9 minus 11 over 4. And x equals, let's get negative 5. That was a negative over 4. There we go. Negative 5. Nobody said no. And x equals negative 9 plus 11 over 4. This is negative 20 over 4. There's negative 5. This is 2 over 4. And there's the 1/2.
Because there's a common factor we could take out. And all you had to do was look. If there isn't, then I have to plug in the big numbers. If there is, the numbers become much more crunchable. But the first step was undo the fractions. Don't plug in 14 over 3 as your A. Because now you have fractions in your square root. That's another issue. Okay, bonus question. That's for the bonus question. Yeah.
So after factoring out the 7, what happens with the derivatives?
Well, we're only solving for x. 7 doesn't have an x, so I mean I could let 7 equal 0, but that's not true.
Or was it factored out? It's kind of.
Well, here's what happens. If I divide both sides by the 7, then I'm just left with this. The 0 divided by 7 is just left. Okay. That's a good question. Been years since somebody asked that.
I think a negative drive.
Right. You hear from this?
Yeah.
So I have negative 9 minus the 11. So that gives me negative 20. Negative 20 over 4 is negative 5. Over here, I forgot to put it was negative 63 minus 77. So that was negative 100 over positive 20. That's how it's now. I didn't put the negative my first time here. And if I plug in negative 5, let's do it here. Negative 5 squared is positive 25. So that's 2 times 25. So that's 50. 9 times negative 5. That's negative 45. And then minus 5. So 50 minus 45 is 5. 5 minus 5, 0. What else?
Number 11.
Number 11. Here's
You know, for number 13, there was a reason why I asked this question, because as it is written in the bonus, you're gonna have fractions that you want to undo before you plug it into the quadratic formula. Now, same thing right here with number 12. Just like the bonus. But once you undo the fractions, it basically becomes just like a regular test question. There's something very specific as to the way number 11 is written. And it's an issue that always seems to be twisting somebody's arm. Nobody believes me. Where I beg and plead, please, when you're solving, no matter what method you use, quadratic formula, complete and square, factoring, please keep your square term positive. If you're factoring, you want to have a positive square term. Completing the square, it has to be a positive x squared anyway, 1 times x squared. When you're using the quadratic formula, you want to, figure out what a is. You want to substitute a positive number for a. Too many signs, it's harder to keep track of. So keep your a x squared, make that a positive. I know it's so much easier to just subtract 6 from both sides. There's just one thing. I'm so tired. But if you want to get it right, I see so many people get it wrong because they just subtract 6. You're going to add, and you got to show the step, because I see people go, they minus 6, and so they have this, but then they go, all right, 0 equals positive 5. They just change the sign. They move the 6 over, but they just magically change the sign. I take off points. You don't get to use magic. You better have a lightning bolt star in your forehead. You're going to add 5x squared to the both sides. So we have positive 5x squared on this side. Got to subtract 9x. So everything comes over, and we have 0 on that side. 5x squared minus 9x, and that's a positive 6 equals 0. Square term positive. No common factors, so we can't do that little nice thing we did in the last one. So make a list of A, B, and C. And again, please put it underneath. Make sure your terms are in the right order. It should go the square term, x to the first, constant, equals 0. So underneath, A is equal to a 5. B is equal to -9. C is equal to positive 6. You got to know the quadratic formula by heart. So every time you use it, you should write it down. X equals the opposite of B, plus or minus, square root, B to the second, minus 4 times A times C. The whole thing divided by 2 times A. That's steps 1, 2, and 3. Then we substitute. Just substitute. Don't worry about trying to solve. X is equal to the opposite. B is -9. So it's the opposite parentheses of -9. Plus or minus the square root. If you're going to square this, you better put it in parentheses. -9 squared. Without the parentheses, there's no way to get it correct. Minus 4 times A, which is 5, times C, which is 6. All over 2 times A, so 2 times 5. And that's the stuff that I'm looking for, because there I can find out where, if you don't get it right, I can figure out where the mistake is.
And if I can figure out where the mistakes are, then I can figure out the partial credit. If there's no work or the work isn't justifying your answer, then the partial credit goes lower.
So that's now positive 9. Still plus or minus. Square root. Negative 9 squared is positive 81. This is a negative times a positive times a positive. So it's going to stay negative. Minus. 4 times 5 is 20. 20 times 6 is 120. All over 10. Neg 81 minus 120%. 32,
Right.
39, but
Negative.
negative 39. So simplify everything we can. X equals. The only thing we can simplify is poke out the I, plus or minus. This is I square root 39. Because 39 is just 3 times a 13, nothing's going to escape. But you have to poke out the I. 9, I square root 39, and 10 have no factors in common. So it's not going to reduce at all. You can leave it just like that. Or if you want to be sure, you can do the splits and still see that nothing reduces. 9 over 10, plus or minus, I square root 39, all over 10. 9 over 10 can't be reduced. I over 10 cannot be reduced. You can leave it either way. Yeah. Eight to square. So you have to show the completing the square method. Okay. Your mandatory test question is not going to have that leading coefficient of 5. So in other words, your step 2 will be really nice. It'll just be 1 times x squared. But the bonus question will look just like this, something like this. Step 1. Isolate the constant. The constant is this 8. So you subtract 8 from both sides. And you want to leave an empty space where that constant was. So 5x squared plus 12x, the little empty spot equals negative n. Step 2. The only way we can complete the square is it has to be 1x squared. If a is not a 1, you have to divide all of the terms by whatever this a is. A is a 5. So we divide all the terms by 5. If you can reduce, you want to reduce. So there's x squared. 12 over 5 does not reduce. So that's 12 over 5 times x. Still an empty spot equals negative 8 over 5. So that's step 1 and 2. Step 3 is where we actually complete the square.
Step 3 is you take half of B, then you square it, and then you add that to both sides. Remember what I told you.
I actually write this out. What's the B right? 12/5. So I write it out. 1/2 of 12/5. 1/2 of the B. Half of 12/5 is 6/5.
What did I do? I simplify the 12.
2 goes into 12, leaving a 6. This is 1/2 times 2 times 6/5, and I can reduce the 2's, leaving 6/5. So 6/5 is my half of B. Then half of B, and then I put parentheses like this, and I square it. Half of B, then I square it. 6/5 squared is 36/25. We add this to both sides. So we have. This is now x squared plus 12/5x plus 36/25 equals. All right.
And take a trip back to the 5th grade and actually add a couple of fractions together.
-8/5 plus 36/25. If you're going to add fractions, you need a common denominator. You have a 5 and a 25. What would the common denominator be? 25. To change this fraction into the denominator with the 25, you have to multiply by 5/5. So the numerator is now 40. -40/25 plus 36/25.
-40 plus 36.
Is -4/25.
No decimals. Leave it as a fraction. The whole purpose of what just happened,
We made a perfect square on this left side. We made a nice, it's either A plus B, perfect square, or we made an A minus B, perfect square. So let's look at this. First times first is x squared. What times what makes x squared? X times x. Both of these signs are positive. So is it a minus minus or plus plus? The plus plus. And then don't overthink it. Last times last is the 36/25. It's a fraction. The numerator is 36. So what times what is 36? 6 times 6. The denominator is 25. So the denominator, what times itself is 25? 5. X plus 6 this squared gives me this. Now here's why I write it on the side. I write out half of B, then I square it. First of all, I want to get it right. But second of all, here's that nice little coincidence I told you about. Half of B, right here, is going to up right there. But I've seen people go, all right, half of 12/5, and they go 12/10. They don't simplify. Then they square it, and they write down 144/100. And that's what they add to both sides.
Will it work? Yeah. But when you can simplify, simplify. That would be a mess. It'll work, but it'll be a mess. More work at the end.
Half of 12/5 is 6/5. Because 12 reduces with the 2.
So now we have this.
X plus 6/5 squared. Don't forget it's a negative 4/25. Then you take the square root of both sides, because now it's just square root method. So x plus 6/5. Don't forget the plus and minus. Square root of a negative, we're going to poke out the I. And then we have a fraction. This is just square root 4 over square root 25. What's square root 4?
2.
2. What's square root 25?
5.
So it's 2/5. So it's do yourself a favor, go 2i over a 5. If you go plus or minus 2/5 times I, that's fine. But you got to be careful and not go plus or minus 2/5i. Because that looks like I is in the denominator, and that's a different number. So if you really want to be careful, just put it in the numerator. These two are the same thing. 2/5 of an I, 2i over 5. This is 2 divided by 5i. But if you want to be safe, do that. Last but not least, remember, we're still solving for x. We subtract 6/5. So x equals negative 6/5 plus or minus 2i over 5. And you can't go any further because you can't combine the negative 6/5 with the 2i. It's imaginary. And leave it like that. One step at a time. And again, this would be bonus level. But your test question is the same steps without having to divide by 5. Completing the square, same steps, just not having a fraction in the middle. What else?
Number 18.
18. Okay, don't forget about the other ones that you can pick any way you want. Try that. Waiting all day to say that. Okay, 6 minus 1 over x equals 1 over x. Well, first of all, it's not even a quadratic because x squared is in the denominator. So undo the fractions. What's the least common denominator that's going to undo an x and an x squared? What? X squared. First of all, if to undo this x, I'd multiply by an x. But x is not going to undo x squared. I would still have an x down here. To undo an x squared, I would have to multiply everything by an x squared, and an x squared. X goes into x squared, leaving x to the first. X squared reduces completely. I have 6x to the second minus, this is x times 1. Let me clean that up. It's x times x squared times 1 over x. X times 1, so minus x equals X squared reduces equals 1. So now you make one side 0, subtract 1. And you get 6x squared minus x minus 1 equals 0.
Now that you don't have a fraction anymore, or fractions, pick the method you want to use to solve it. Factor, please try factoring, complete the square, quadratic formula, whatever you want to choose.
For the sake of time, there's no common factor. 6x squared is either 1x times 6x or 2x and 3x. Pick one.
3x.
So 2x, 3x. So we know we'll make 6x in a second. Now, last times last is a negative. So my signs have to be different. I have to have a positive times a negative to make a negative. And here's the best news about factoring for here, for this problem. Last times last is 1, and the only way to make a 1 would be a 1 times a 1. That's it.
So there's not a lot of choices, which means if it factors, we'll be done quickly. If it doesn't factor, we'll know quickly.
Outside times outside, 2x times negative 1, negative 2x. Inside, inside, it's positive 3x. That adds up to positive 1x. I don't want positive. I want negative. So what do I do if I have the wrong sign with the right amount?
Solution.
Switch the what? Switch the sign. Well, technically switching the ones wouldn't help. So I change the sign, switch the sign. That's now negative, that's now positive. Outside, outside is now positive 2x. Inside, inside is now minus 3. 2x minus 3x is the negative x.
So it factors. You can do any method you want. Factoring is the most efficient, quickest, simplest, easy way to get there.
And you factoring is a skill you have to know. You let each one equal 0, so 2x minus 1 could equal 0, 3x plus 1, 0, add 1, 2x equals 1, divided by 2. So this x is 1/2. And then subtract 1. 3x is equal to negative 1 divided by 3. So this x is equal to negative 1/3.
Can you do the 7 up here?
I apologize. I took a picture of what I wrote yesterday. I'm going, my gosh. My brain and my handwriting have deteriorated beyond belief. Uglier and uglier. The 7 directions say solve by factor. Um, 16x squared equals 24x plus 112. Okay. Has to be equal to 0. Again, here I'm going to go with, please keep your square term positive. I know it's easiest to just move 16x squared to the right side and have negative 16x squared plus 24x plus 112, but trying to factor that, not going to be nice. Keep the square term positive no matter what you're doing. So that means I'm going to have to bring 24x and 112 over to the left. Subtract 24x from both sides. Subtract 112 from both sides. So 16x to the second minus 24x minus 112 equals 0. Now, before you go any further, the first step of factoring, take out a greatest common factor if there is one. Because right now, if you go straight to in parentheses, 16x squared, you have x and 16x. You have 2x and 8x. You have 4x and 4x. Not to mention 112, you have 2 times of 50, well, 1 times 112, 2 times of 56, 3 times 34, 4 times a 20, 28. 5 doesn't work. 6 times 6 doesn't work. 7 times 16. 8 times 8 times 14. Yeah, okay, I'm not going to keep going. Look at all the possible things you can pair up the match. You'll be here forever. And you'll be angry at me because you're doing one problem per hour. That's not how it is. There must be a greatest common factor. You could take out a 2, but if you take out a 2, then you have an 8, a 12, and a 56. They're still even. So I could take out another 2. Or maybe I could take out something bigger. 8. 8 goes into 16, 8 goes into 24, and if you just check on the calculator really quick, 8 goes into 112 14 times. Now 14, I wrote that. So I can factor out an 8, and that's what you're supposed to do, and that's why I gave you this question. I gave you this technical question for 2 reasons. Number 1, to make sure you keep your square term positive, bring the other 2 to the left side. Then take out the greatest common factor first. You're going to factor out an 8. So you can see an example at its highest level. You're going to factor it out, you divide everybody by 8. So this is 8 times 16x squared is now 2x squared. Minus this is now 3x. Minus this is now 14. Equals 0. So this is 8 times. Now we set up this. Before 16x squared, x and 16x, 2x and 8x, 4x and 4x. But 2x squared, the only way to make a 2x squared is x and 2x. There's only one way. So it has to be x times 2x to make 2x squared. It's nice when there's only one choice. Last times last is a negative. So the signs have to be different. One's a positive, one's a negative to make a negative. And then last times last has to be a 14. So it's either going to be 1 times 14 or 2 times 7. Versus 112, which was a whole bunch of different ways. So pick one. 1 and 14 and 2 and 12. 2 and 7. 2 and 7. So here's the nice part. Now think ahead. 2 and 7. This is a waste of time. Putting the 2 in here. Putting a 2 with the other 2 means I can take a 2 and factor a 2 out because they each have a factor of 2. If I could factor 2 out right here, I should have been able to take another 2 out from here because there's a common factor of a 2 again. But there wasn't, so there shouldn't be. So putting a 2 with this 2 would never work. The only way these 2 can fit with what I have The 7 has to be here and the 2 would have to be there. You could try it, but it won't make the middle. Check the middle. Outside times outside, x times -7, -7x. Inside, 2 times 2x, positive 4x. -7 plus 4, -3 in the middle.
Can you do that again? I'm sorry.
Uh,
The last part,
okay,
the very last part.
so this part.
Yeah.
Okay. So when we check to see if it works, we're checking from FOIL. We're checking the OI part. OI stands for outside times outside plus inside times inside. Okay, so first times first, outside times outside, inside times inside, last times last. The OI ends up adding when you go outside times outside, inside times inside, because that's how this makes it. Outside times outside, x times -7. -7. Inside is positive 4. That's gonna add up to the middle. First term, first times first is this. Last times last is out. The middle is 4. Outside times outside, inside times inside, -7x, positive 4x, adds up to -2. Okay?
It's just also with the positive and the negative, the two right there, the positive and the negative is like kind of tricky.
So if you have ax squared plus bx plus c, the only way you can get a positive here and a positive there, when they're both positive, your factoring has to have both positives. So when you're trying to factor, you look at the last sign. Last times last is a positive, and the middle is a positive. My signs have to both be positive. You might have the last sign is a positive, but the middle is a negative. To make a positive, you can also do a negative times a negative, and that makes a positive. In the middle, the OI, 2 negatives add up to a negative. So if it's a negative and a positive, they're both negative. If it's both positive, they're both positive. So you look at the last sign. If it's positive, it's either this or this. How do you know? Look at the middle. If it's minus, if they're both plus, then the only other things, if the last sign is negative, the only way to get a last sign negative, last time last have to be opposite time. The last positive times the negative makes a negative here. So if the signs are negative here, they have to be different here. That's the only way the signs will work. Okay. What is that? This one equals 0. 2x minus 7 equals 0. Subtract 2. This x is -2. Add 7. 2x equals 7. Divide by 2. This x is equal to 7/2. What else? 19. I know you haven't asked, but please don't forget about what I said about number 16. It's perfectly set up for the square root method, just like the one on your test will be. Whatever will be, will be. So 19 comes with fraction. And I made sure on the test question to put a little extra room in between the plus and the fractions. And it equals, so you have more room to write what you should have been writing. So we want to undo the denominator, we want to undo the fraction. To undo the first fraction, we'll have to multiply everything by an x minus 2. But an x minus 2 is not going to undo this fraction. We have to multiply by an x minus 1 as well. So the least common denominator is x minus 2 times an x minus 1. Now, before I go any further, think ahead. You can't divide by 0. So think about the possible answers that we'll have to throw away just in case. If I get x equals what? I can't use 2. If I get x equals 2 and I try to plug it into the original problem, 2 minus 2 would give me 0 in the denominator. So if I get 2, I can't use it. I got to toss it. Over here, this x cannot equal 1. It can't equal 1. Because if I get x equals 1, 1 minus 1, I get 0 in this denominator. So I cannot use an x equal a 2 or a 1. Just in case I'm thinking ahead. Okay? It's like getting a gift certificate to TGI Friday because it doesn't exist anymore. Okay? Or getting a gift certificate to a place that, well, when I was in college, Tequila Pete's. It doesn't exist anymore. Or Buzzard Lips. That doesn't exist anymore either. The Alligator Club, that burned down. Okay? Mr. Ed's Pub and Grubs, that's gone too. Yeah, there used to be a place called Mr. Ed's Pub and Grubs. So, we multiply every term individually by x minus 2 times x minus 1. Okay, so x minus 2 reduces. Take your time. You can multiply right now, but I'm not in a hurry. X times x minus 1 plus x minus 1 reducing. I'm left with 2x times that x minus 2 equals. Here's what I want to get across to you. I know you're supposed to multiply from left to right. So you would distribute the 6, and you get 6x minus 12, and then you got to multiply times x minus 1. That tends to get a little messy when you try to multiply 6x minus 12 times it. Here's a little bit of advice. It's a little nicer to multiply these two first. So this is 6 times x squared minus x minus 2x plus 2. Because now I'm just going to distribute 6 into 3 simple terms versus trying to distribute 6x minus 12. Okay. X squared minus X plus two, or positive 2x times X, that's a positive 2x squared. 2x times negative 2 is a minus 4x equals 6x to the second minus 18x plus 12. Slow down and simplify first. Step one is simplify completely. Combine your like terms. How many x squareds do we have?
Yeah.
Two terms, but how many total? X squared plus 2x squared. What's that add up to? One x squared plus 2x squared is 3x squared. You're only going to get x to the fourth if you multiply x squared times x squared. And how about this? Have we gotten x to the fourth anywhere at any time before?
Yeah.
So that's gotta let you, okay. Until I haven't got there yet, so stop. You know, it's like, am I going in the right direction? Okay, slow down. Maybe come up and ask, just in case. And then negative x minus 4x. What's that? Negative 5x. Good. And then equals 6x squared minus 18x plus 12. All right, so which side should we bring everything over? Left or right? Going to the right, because that way x squared stays positive. Subtract 3x squared. And we're going to add 5x. Zero equals 3x squared minus 13x plus 12. Now we can actually solve. Everything we just did was getting it ready and letting it equals it. I'm going to say try factoring quicker. If it doesn't factor, do something else. But there's no common factor. So 3x to the second. The only way you're going to make 3x squared is 1x times 3x. So that's going to give you 3x squared. Now watch the signs now. The last sign is positive. So it's either positive times positive or negative times negative. The middle is negative. If I have two positives will not add up to a negative. So the signs have to be negative and a negative. A negative times a negative will be a positive, and two negatives will add up to a negative. Has to be minus minus. This is the only way to make a 3x squared. This is the only way the signs are going to work. Then we want to make 12. Last 12. So it's either going to be 1 times 12, 2 and a 6, or 3 and a 4. What do you want?
3 and 4.
3 and 4. So 3 and 4, putting 3 with 3, waste of time. So the only way it works would be 3 here and 4 there. Outside times outside. X times negative 4, negative 4x. Inside times inside. Negative 3 times 3, negative 9x. Negative 4x minus 9x. Look at that. Negative 13x. So it does factor. Yes, fine. Yes. Seriously. Unless you do the other method, quadratic formula, whatever, but make sure you have everything squared away. So now you just go x minus 3. Could be 0. 3x minus 4. Add 3. X minus 3 is 3. Add 4. EF equals 4, divide by 3. This X is 4/3. Double check and make sure we didn't get a throwaway answer. Did we get a 2 or a 1? Nope. So X is equal to 4/3 and a 3. Okay. Have your homework ready to be turned in, stapled, filled out, assignment sheet. Hold up your homework scores, first and last name on it, nice, neatly stapled in order. And be ready for it.